Hello friends, welcome to the Why Things channel. Today, we are solving a mystery that we often see when we look at the sky. Why do planes leave trails in the sky? What are those white lines behind the planes? Cloud, smoke, or something else? Why do these traces sometimes disappear immediately and sometimes remain in the sky for hours? In this video, we will explore the scientific secret of aircraft trails, the role of the atmosphere in this process, their effects on climate, historical context, and even false chemical trail myths. If you are ready, fasten your seatbelts and let's go on this sky journey. 1. What are contrails? The scientific explanation of white trails in the sky. The white trails left by airplanes in the sky are scientifically known as contrails, condensation trails, and are a completely natural phenomenon. So how do these trails form? It all starts with the way jet engines work. When airplanes burn kerosene fuel, the engines produce carbon dioxide, CO2, water vapor, H2O, and small amounts of nitrogen oxides and particles. At high altitudes, usually 8 to 12 kilometers, the air is extremely cold, the temperature drops below -40 degrees Celsius. In this cold environment, the water vapor coming out of the engines instantly condenses and turns into small ice crystals. These crystals form the white trails we see in the sky. Contrails are actually artificial clouds and act like natural fog or steam in the atmosphere. Small particles in the engine exhaust, such as soot or sulfur particles, accelerate the formation of these crystals, just as clouds condense on dust grains. An interesting detail. Contrails can occur not only in jet aircraft, but sometimes in propeller aircraft as well, but are more common in jets because they fly at higher altitudes. Also, the aerodynamic pressure drop created by the wings of the aircraft can occasionally create wing contrails, especially in humid air at low altitudes. 2. The dance of the atmosphere, humidity, temperature, and contrail persistence. The formation of contrails and how long they persist in the sky depend on atmospheric conditions. Two main factors come into play: temperature and humidity. Temperature, at high altitudes, when the air is below -40 degrees Celsius, water vapor quickly turns into ice crystals. If the air is warmer, contrails either do not form or evaporate immediately. Humidity, when humidity is high, ice crystals grow and persist for a long time, sometimes hanging in the sky for hours. At low humidity, the crystals sublimate, evaporate quickly, and the trail disappears. In humid weather, contrails can form into artificial clouds called contrail cirrus. These clouds appear thin, feathery, and spreading like natural cirrus clouds and can cover large areas of the sky. Wind and air turbulence also affect the shape of contrails. Strong winds can spread the trails, creating wavy or feathery patterns. Meteorologists know that persistent contrails are a sign of moist weather. It could be a sign of rain or a storm ahead. Contrails mirror the atmosphere, telling us about the temperature and humidity profile of the air. 3. Climate impacts, the dual role of contrails. Contrails aren't just a pretty sight in the sky, they also have a measurable impact on the climate. Persistent contrails act like cirrus clouds, creating two opposing effects. Cooling effect: during the day, they can cool the planet by reflecting sunlight, the albedo effect. This slightly reduces global temperatures. Heating effect: at night, they contribute to the greenhouse effect by trapping heat in the atmosphere, which warms the planet. Studies show that contrails contribute less to global warming than aircraft CO2 emissions, but their impact increases with increasing air traffic. For example, in busy flight corridors, over the North Atlantic or Europe, contrails can affect local climate. Scientists have proposed solutions to reduce the contrail effect. Keeping flight paths away from humid regions can reduce contrail formation by up to 50%. In addition, cleaner fuels and engine technologies can limit contrail formation by reducing particulate emissions. This is an exciting step towards reducing aviation's environmental footprint. 4. The chemtrail myth and historical context. Contrails are often confused with chemtrail theories, unfortunately. This conspiracy theory claims that airplanes are spraying chemicals, but scientific evidence shows this to be completely false. Contrails are made up of nothing more than water vapor, ice crystals, and small amounts of exhaust gas particles. Persistent contrails are noticeable only because they stay in moist air for long periods of time. NASA, NOAA, and other scientific organizations have repeatedly stated that these trails are a natural phenomenon. The history of contrails is as old as aviation itself. During World War II, pilots noticed that contrails were revealing aircraft to enemy radars because they left a distinctive mark in the sky. During this period, bombers flying at high altitudes had to change their flight plans to reduce contrails. In addition, the grounding of flights in the United States on September 11, 2001 provided a unique opportunity to study the impact of contrails on the climate. With the flight suspension, the skies were left clear of contrails, and scientists were able to measure how these clouds affected temperature fluctuations. Contrails are a fascinating subject, both historically and scientifically. Here is the fascinating story of the trails left in the sky by airplanes. Contrails are the dance of water vapor in cold and humid high altitudes, a reflection of the atmosphere. They both affect the climate and tell us the secrets of the weather. Despite the chemtrail legends, these trails are a scientific miracle, a meeting of nature and technology. What do you think about contrails when you look at the sky? Share your most interesting airplane moment in the comments, we will read it with interest. If you like this video, don't forget to press the like button, subscribe to the channel and turn on the notification bell. See you in the next why question. Keep watching the sky.